Multi-agent systems usually fail quietly before they fail loudly. One fleet I reviewed had a research agent hand a builder agent a neat paragraph. The library supports streaming, authentication is simple, should take an hour. The builder shipped code around that paragraph. Then verification found the library only streamed on the paid plan. The authentication note came from an old issue, and should take an hour had become an implicit budget. Nobody lied. The handoff was just prose, so the next agent guessed the contract. The naive approach is to pass the transcript forward. Research agent talks, planning agent reads, execution agent reads even more. Verification agent tries to infer intent from the whole blob. That feels flexible, but it destroys reliability. Verified facts sit beside uncertain claims with the same tone. A constraint from the user gets mixed with a suggestion from an agent. Open questions disappear because they are embarrassing. The next phase starts by interpreting language instead of checking state. In production, every phase boundary is where responsibility changes. If the boundary is vague, responsibility leaks into the transcript, and transcripts do not own anything. The pattern is typed handoffs. Every transition in the loop passes a small packet with a known shape. Research does not hand off a conversation. It hands off a research packet. Planning hands off an execution plan. Execution hands off a completion packet. Verification returns a verification report. Each packet has required fields, allowed uncertainty, and validation rules. My opinionated rule is this: the next agent may read the packet, but it should not need the full transcript to understand its job. If the packet is missing meaning, repair the packet. Do not ask the next agent to be clever. The packet chain diagram is simple. ResearchPacket flows to planning. Planning creates execution plan. Execution creates completion packet. Verification creates verification report. Before each phase, run a handoff validator. A useful research packet has verified facts, and each fact has evidence and confidence. It also has uncertain claims, constraints, and open questions. A useful execution plan is not a paragraph. It is tasks with IDs, depends on lists, actions, and per task success condition fields. The validator response should be boring, valid true, or valid false with errors and a repair request. Consequential fields need provenance, source document, logline, test result, human instruction, or previous packet ID. Say a coding agent must add file upload support. The research agent returns a research packet. Verified fact: current backend uses object storage client version 3. Evidence is package lock hash, confidence 0.98. Uncertain claim: image resizing may already exist. Reason uncertain is no test coverage found. Constraint: keep public API compatible. Open question: maximum file size. The planner cannot turn that into vague work. It creates tasks. T1 adds storage adapter. Success condition is integration test uploads and retrieves a file. T2 adds size validation. Depends on T1. Success condition is failing request above configured limit. Execution reports changed files and test output. Verification checks the provenance before judging done. Typed handoffs are not magic. A schema can be ceremonial. All the fields exist, but success condition says works correctly. Reject that. Evidence can go stale between research and execution, especially in web workflows or fast-moving code bases. Provenance says where a claim came from, not that it remains true forever. Small packets also have a trade-off. If you make them too small, agents lose context and ask for repairs constantly. If you make them too large, you have rebuilt the transcript with field names. The validator costs tokens, latency, and engineering time, so reserve strictness for boundaries that matter. This pattern sits in the middle of loop engineering. It connects state management to verification. Instead of hoping the model remembers, the orchestrator stores packet state. Instead of letting agents argue, the validator enforces contracts. It also connects to budgets. Maybe a packet gets 2 repair attempts, then escalates or stops. It connects to stop conditions because a verification report can say pass, fail, or blocked with evidence. In the patterns tier, we are building the discipline that lets fleets scale: clear transitions, small state, explicit ownership, and no mystery meat between agents. Take 10 minutes and pick one handoff in your own automation. Maybe research to plan, plan to code, code to review, or review to publish. Name the packet. Add 5 required fields. At least one field must separate verified facts from uncertain claims. At least one field must describe success in testable language. At least one consequential field must carry provenance. Then write 3 reject rules. For example, reject any planned task without an ID, dependency list, and success condition. Reject any factual claim without evidence. Reject any packet that asks the next agent to inspect the whole transcript. 3 beats to remember. First, transfer responsibility, never the transcript. A packet says what the next phase owns. Second, label confidence. Verified facts, uncertain claims, constraints, and open questions are different things, and your schema should make that impossible to miss. Third, validate before the next agent runs. If the handoff is bad, repair the handoff, not the downstream task. That is how multi-agent systems stop guessing at phase boundaries. New loop engineering episode daily on this channel, building from foundations toward reliable fleet-scale agent operations.